Welcome to the Walton Pi. Today we're going to be talking about infinite limits. So how do we show that the limit of a function is going to be infinity? That's going to be our big question here. So we're going to say that a function defined on some open interval containing a, with potentially f not defined at a, the limit of f of x as x approaches a is infinity if for every big M bigger than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta, then f of x is going to be greater than m. So this is similar to the epsilon delta argument, except instead of saying we are some distance close to m, we can't say we are close to infinity because any number that we're looking at is finite and thus far away from infinity. So we have to say that our definition of being close to infinity is going to be bigger than a really large number. That's going to be how we're defining something to be close to infinity. If we're trying to show something, the limit of a function goes to negative infinity, then it's pretty much the same argument. The only difference is we are going to say it's less than n, where n is some really large negative number, like negative 10 trillion or negative 10 Google or something like that. So that's how we would say that the limit is negative infinity. So this is a way that we can visualize how they differ from the two. So both of them have the condition that is x gets close to a, so we are in some delta neighborhood of a, meaning 0 is less than the absolute value of x minus a is less than delta. We are some distance delta or closer from a. If it's a finite limit, then the absolute value of f of x minus L is less than epsilon, meaning we are less than epsilon away from the actual limit. Now we can't say we're less than epsilon away from infinity, so the way we do that is we say there is some very large cutoff value that we're going to call m, and then if we are inside our delta neighborhood, we are going to be bigger than that value of m. So for example, let's show that the limit as x goes to 3 of 2 over x minus 3 squared is equal to infinity. So for m bigger than 0, we are going to let delta be equal to the square root of 2 over m. If you're wondering where we got this is going to basically be a very similar process that we went through with the finite limits, except instead of starting with absolute value of f of x minus L being less than epsilon, we're going to start with f of x is bigger than big M, and then we would be able to go from there. So we are going to let delta be the square root of 2 over m. So that says that for x satisfying 0 less than the absolute value of x minus 3 is less than delta, so for x's inside our delta neighborhood, we have f of x is equal to 2 over x minus 3 squared, but x minus 3 is less than delta, so that means that 2 over x minus 3 squared, that's bigger than 2 over delta squared. Because if we increase the denominator, that decreases the value of the overall fraction. So that means that we have f of x is bigger than 2 over delta squared, but delta was the square root of 2 over m, so delta squared is 2 over m. So that means we have 2 over quantity 2 over m, which is equal to m. Therefore, the limit as x goes to 3 of 2 over x minus 3 squared is equal to positive infinity. I hope this was helpful to understand the idea of infinite limits. Please check out my next video where we will be going over some examples where we will walk through the entire process together. And please like and subscribe if you have not already. It helps me to be able to continue to make these sorts of videos. Have a great day and good luck with the rest of your math.